I've finally recovered from a fantastic yet exhausting RAPID TCT 2024. So it's time for me to put together this recap and highlights video from the event, which was held in Los Angeles from June 25th to 27th. I'll cover, briefly, some of the highlighted activities, but spend the bulk of my time on new product announcements with my observations of some overarching trends and themes. With that first theme being a palpable shift from hyped-up self-promotion to a tone of honest pragmatism. Sure, some of the new players were making change-the-world claims, but much of the conversation and messaging was better balanced and focused on the needs of the customer and solving problems. And the humble honesty of where we are and what needs to be done started with the statements uttered by the leaders of well-known additive companies. I'm Todd Grimm, an advisor for RAPID TCT and president of Grimm Associates, an additive manufacturing, consulting, and communications company. I'm going to start with the highlights of the RAPID TCT program. From start to finish, SME and RAPID News Group pulled out all the stops to make this the best RAPID TCT that I have experienced in the 30 years that I've been attending. And all of the participants, exhibitors, speakers, and attendees responded in kind. The event kicked off with an Executive Perspectives panel, which occurred daily. Speaking to a packed room, 5 industry leaders engage in refreshingly honest dialogue about where we are and what we need to do to advance. Owning up to self-inflicted wounds, the panelists' message centered around being excited about additive while being humble and honest about the role it plays today and the hard work needed to advance to our desired future. Those panel discussions took place on the main stage, which was free for all to access. After the panels, the main stage hosted a full daily agenda of keynote presentations, award presentations, panels, and special features like the Pitch Fest for new, up-and-coming additive players. Combined with a packed show floor, RAPID TCT was nonstop, offering something for everyone. To allay the fatigue of constant conversation and insight gathering without taking attendees out of the zone, RAPID TCT had its Hollywood showcase on the show floor. In the nearly 1,000 square feet showcase, attendees could meander through an exhibit of larger-than-life movie characters and make an appointment for a full body scan in a self-contained mobile photogrammetry studio. Now, I'm not one to be smitten by stardom, but it was pretty cool to be standing on the very spot where Beyoncé stood a few months prior to be 3D scanned. And I've got to tip my hat to Gentle Giant Studios and Direct Dimensions, who provided all of the assets that were on display in the showcase. Day 2 concluded with the 3rd annual AM Industry Celebration. The atrium of the LA Convention Center was buzzing with energy and enthusiasm. Fueled by food, beverage, and entertainment, RAPID TCT participants engaged with old friends and made new ones with a continuation of the excited but pragmatic tone of the event. Thanks to the efforts of the event organizers and the contributions by speakers, exhibitors, and attendees, RAPID TCT 2024 was phenomenal. With that in mind, I will join the hundreds of others I spoke to who said they will definitely be attending RAPID TCT 2025, which will be held April 8th to 10th in Detroit, Michigan. Now, I have one big regret, though. With so many exhibitors, activities, and presentations, I simply could not see all that RAPID TCT had to offer. Even though I spent 16 hours on the show floor, I only managed to visit 1/3 of the booth. Now, that's partly due to spontaneous aisleway conversations, but mostly due to my style. I don't do a run-and-gun approach. Instead, I invest upwards of 20 minutes in each booth to gain a better understanding of what is being offered and why that matters. I mention that so that you are aware that my highlights from the show floor are incomplete. And yet, I have product news from 18 companies to share, plus some brief mentions of another 12. The first theme that I observed was that tone of the Executive Perspectives panel playing out on the show floor, almost as if a pre-event doctrine had been laid out for all to follow. The innovations brought excitement, while the advancements were positioned humbly as user-desired improvements to advance additive further into production applications or just to serve current customer needs in a better fashion. With that in mind, it's no wonder that I have 8 software-oriented highlights to offer. That'll be followed by 1 inspection tool, 5 polymer systems, 1 composite solution, and 4 for metal additive manufacturing machines. The last item I want to note is that I'm omitting all of the news covered in my pre-event videos if I didn't secure additional insights. That news comes from companies that include 3DX Tech, Additech, Additive Industries, Additive Solutions, AlphaStar, BASF Forward AM, which has recently been spun off to be its own entity, Boston Microfabrication, Formlabs, Henkel, Juggerbot, Make It, Meltio, Orbital, Quantica, Renishaw, Shenzhen Kings, and Triditive. In the software category, I'll start with 3D Spark. It offers a decision-making tool that assists in selecting the right process for your parts. Those decisions are based on manufacturability, part cost, time to manufacture, and that's across the full supply chain, and sustainability. What caught my attention is that this isn't just a tool for assessment of additives applicability. It also produces recommendations for conventional parts. So there's a recommended manufacturing path for every part that's fed to the software. Now there's 2 key pillars to making that happen: an advanced algorithm, and that algorithm is fueled by customer-specific parameters rather than a generic data set. During onboarding of a customer, the data set is populated with the customer's actual data for both additive and conventional processes, which the company states provides very accurate assessments, citing plus or minus 5% variance between actual and estimated part costs. 3D Spark's target markets are large OEMs and service bureaus for automated quoting. nTop announced its nTop 5 software for design, generative design, and topology optimization, offering computational design technology. What's new with the version 5 is an implicit modeling kernel for performance and precision combined with an expanded ecosystem within nTop's core developer library that now includes mechanical simulation, computational fluid dynamics, and build preparation tools. That expansion includes 5 new integration partners that can read and query implicit models natively in their software for more efficient end-to-end workflows. Those partners are Autodesk, Materialise, Hexagon, Intact Simulation, and Cloud Fluid. Last year, General Lattice announced Frontier and its digital Lattice library, which is an archive of materials plus process parameters for various Lattice designs, supported by lengthy lists of the associated mechanical properties. Essentially, General Lattice does all of the testing to put you on the fast track with confidence to incorporate lattices in your design. This year, it has launched Frontier Integrations, which allows you to select and apply a desired lattice to your part. My understanding is that the integrations are limited to those machine and material collaborators for which they have healthy data sets so they can present accurate representations. And that's from companies such as Formlabs, EOS, BASF, and Photocentric. Once the lattice is applied, you can then have it printed through its validated supply chain network. Note that I'm unsure if you can download and print it on your own machines. While robust, this web-based application is affordable, just $120 per month per user. Aibuild was demonstrating its new version 2.0 AI solution with an emphasis on the user interface, and it looked quite nice with seamless integration of natural language instructions and visual programming. Where it focuses is on the material extrusion solutions, either fused filament fabrication, FFF, or fused granulate fabrication, FGF, with some DED, for gantry or robot-mounted heads. Its functionality centers on toolpath generation augmented by past print defects and failure information. The dataset upon which the AI draws is largely populated by Aibuild's partner OEMs, but your real-world results can, or will, enrich that data. While it focuses on FFF, FGF, and DED presently, the vision is to become the singular platform for all additive technologies. What I walked away with was a strong sense that Aibuild's team is comprised of straight shooters and bright minds that have the noble goal of helping the industry grow by removing the pain point of time or failure in setting up prints. In the Polymaker booth, Helio Additive debuted Dragon, which is the result of collaboration between the two companies. Like Aibuild, it is addressing the first time right challenge, but also focuses on improving print times, reducing cost, and improving mechanical properties. To do this, it uses simulation and optimization. Its approach is to analyze and simulate all parameters that are baked into the G-code. Dragon uses an understanding of the physics governing material behavior during printing. The resulting accurate prediction of cooling, layer bonding, and stress relaxation can significantly enhance print quality and reduce defects such as warping. Dragon focuses on large format additive, primarily FFF processes, but it states that it will eventually address smaller format machines and other AM processes. Helio offered a free trial at RAPID TCT, and according to their website, that free trial is still available. Materialise featured one announcement at RAPID TCT, that's Magix 28, and highlighted a new product called E-Stage for Metal Plus that was announced back in March. Magix 28 key feature is its new Lattice module that supports beam lattices using lighter datasets for faster processing. Additionally, it offers an improved Nester module for automatic optimized part placement. Accompanying Magix 28, Materialise announced partnerships with Incus, nTop, and EOS. These partnerships provide improved metal AM success rates for laser powder bed fusion, or LPBF, and streamline the design to manufacturing workflow. Also for LPBF, E-Stage for Metal Plus employs physics-based modeling to automate support generation, aiming to streamline metal AM, reduce costs, and minimize complexities. ProfitKey featured nPower Scheduler at RAPID TCT. This software is all about scheduling, full stop. It falls into the MES software category, but beyond scheduling, it doesn't offer other functions common in the MES world. nPower Scheduler is a web-based scheduling tool for additive processes that also supports conventional manufacturing operations. It provides concurrent scheduling of materials, work centers, operators, and outside services across the entire shop floor. nPower Scheduler is ERP agnostic. You can certainly use it with ProfitKey's ERP solution, but you can also use it with ERP from any other company. Its affordable cost model, just $250 per month per controlled asset, and reasonable implementation timeframe of 4 to 6 weeks. That is, if you have your processes well documented and defined before you start the implementation. Those two things make the solution fairly easy to adopt. Authentise partnered with United Performance Metals to offer the Vendor Inventory Management Platform, or VMI for short. It leverages Authentise's software technology to offer comprehensive traceability of key components such as metal AM build plates or powders by integrating Authentise's data-driven workflow with UPM's knowledge of high-performance metals and tools. VMI automatically monitors and replenishes stock and features a remote management portal for live monitoring and management. And manufacturers can keep consignment stock in their warehouses. The software is now in beta testing. Straddling the realms of software and hardware, I have one process inspection tool to mention. Phase 3D was on the show floor showing off its in situ inspection. They reject the term monitoring for metal AM builds to detect, measure, and identify anomalies during the build. It does that on each layer without increasing build time by using fringe projection to measure the powder bed at the micron level. The output is a reporting of build anomalies, item by item type, with corresponding measurements, plus height maps and the ability to pick any point on a bed to grab a measurement. Driving home the difference between inspection and monitoring, Phase 3D had plenty of examples where camera-based monitoring output yields hard-to-see by eye defects, even if you know that they're present. I've shown many images, told where to look, and could not spot the problematic area, which showed up in their inspection reporting. Now, I'll shift to additive machines, starting with polymers. Two new additive players generated quite a lot of buzz on the show floor, the first being Fugo Precision 3D. I reported on them in my pre-event video for Who's New, but I had many questions at the time. After in-depth conversations on the floor, I've wrapped my head around what they are doing and why that matters. The process is called centrifugal 3D printing, and its first machine is called Model A. The way it works is that a drum spins at 3,000 RPM. Within that drum, a sheet of metal is placed along the inner diameter. This becomes the build plate. From the bottom, photopolymers injected into the drum, dosed such that the resin coats the build sheet to the desired slice thickness. And from the top, an array of lasers enters the drum, and it stays there until the build is complete. As the drum spins, those lasers fire to cure the resin. Now, this is a very unique approach to additive with many advantages, including the speed is impressive. Less than 1 hour per vertical inch of part, where vertical is actually the axial dimension in the machine. There are virtually no support structures needed because at 3,000 RPM, the resin is pulling 2,100 Gs, which makes it behave like a solid. After the build, the uncured resin simply drains to the bottom for recovery and reuse. The process is not bound by the usual limits on photopolymer viscosity, and it can be used with filled materials. Also, there's no mechanical moving parts that can wear or fail. Optionally, the Model A can output fully cured parts. To do this, the uncured resin is extracted, a washing solution fills the drum, which is then agitated like a washing machine. The solution is pumped out, and LED bulbs flood the drum with UV light. The next three announcements are all in the material extrusion category, and they point to a welcome trend of addressing customers' true needs rather than playing follow the leader with Me Too products or innovating in hopes that there is a need. With the announcements by 3D Systems, BigRep, and Roboze, we see platforms that are right-sized with attention to speed, reliability, efficiency, and quality. 3D Systems launched the Titan EXT 800, which has an 800 by 600 millimeter build area that's smaller than its 1070 and 1270. This fused granulate fabrication machine, a pellet extruder, boasts a smaller footprint and lower upfront cost to make it easier to adopt and implement. Using components like industrial CNC controllers, 3D Systems states that the EXT 800 delivers speed, reliability, and efficiency. BigRep announced its new Vio 250, which is an FFF machine with a build area of 1 meter by 1/2 meter. This machine is smaller than others in its lineup because the company has found that this size falls in the sweet spot of user needs. Vio 250 is claimed to offer automated, effortless printing, or as one representative stated, an approach that eliminates common operator mistakes. There are a number of capabilities that play to this intent, including automatic bed leveling to get the first layer right, failed print detection, recognizing plugged extruders, and a controlled environment, 50 degrees C build chamber and 120 degrees C bed temperature. Another new FFF machine is Roboze's Argo 500 Hyperspeed. This is an upgraded version of the Argo 500 that's claimed to increase speed, efficiency, and quality. It does that with upgrades to the material deposition flow and to the software. It's outfitted with PolyFlow X for fast, controlled flow, yielding up to 62% faster prints, and it has smart G-code print algorithms to optimize movements and travel for up to 92% print time reduction when used with dual extruders. Argo 500 Hyperspeed has a 500 by 500 millimeter build area and a heated build chamber, up to 180 degrees C. The last bit of polymer news is for those in the medical field. Stratasys announced the J5 Digital Anatomy. It's an entry-level extension of its existing PolyJet digital anatomy capabilities that are for medical modeling of lifelike, patient-specific structures that behave like human tissue, skeletal structures, and vasculature. The price and size of the J5 Digital Anatomy expands access to the medical modeling tools within hospitals and medical device manufacturers and facilities and research institutions. The key benefits target enhanced surgical planning, interactive training, and accelerated development of medical devices. Before I shift to metal additive machines, I have one composite printer solution for you, and it plays to another trend, using the established expertise, technology, and architecture of non-additive solutions. In the case of impossible objects, that means leveraging the best from high-speed 2D printing. It announced that it's now shipping the CBAM 25, which combines fiber cloth, and polymer to manufacture composite parts. The 25 in the machine's name is a reference to its throughput, 25 feet per minute. To get an appreciation of where that speed comes from, let me explain how the process works. It starts with a roll of fiber material that's fed into the machine. First stage is a jetting bar depositing a solution in the pattern of the parts on that layer. That then passes underneath a deposition bar where polymer powder is just flooded over the surface. Wherever the ink was in the jetting process, that powder sticks. Then it passes under a vacuum unit to suck away the undesired material. That then comes out of the machine as cut sheet, which are then stacked. The final step is outside of the machine. This is consolidation, where heat and pressure are applied. There's a lot that this machine has to offer, but two features stand out in my mind. One, it uses vision systems to ensure proper alignment. And if errors are detected, it can recover by reprinting the bad sheets. And two, there's no heating during printing, so parts can be tightly packed without concern for thermal bleed affecting part quality. Impossible Objects is targeting production work, and it has data showing that it's competitive with 6061 aluminum and conventional carbon fiber composite layups. For example, the cost per part is well below the current threshold established by aerospace industry and DoD specs. And for part strength, it showed that CBAM 25 can match that of 6061 aluminum while producing a part that weighs 50% less. The last three items I will highlight are in metal additive. Like Fugo Precision 3D, Grid Logic had the show floor buzzing about its unique approach to 3D printing, something that they loosely call multi-material 3D powder printing technology. For many metal AM parts, hipping, or hot isostatic pressing, is part of the workflow. For Grid Logic, it is part of the process. Its process dispenses metal or ceramic powders directly into a hip-suitable can. No sintering, no binding, no melting. When the process is complete, the can is sealed and sent to the hipping operation, where the material is consolidated into a dense, layerless, near-net shaped part, or parts in one build. And the standout highlight is exceptional diffusion bonds between dissimilar materials. Grid Logic is targeting high-value parts with multi-material needs. Its system deposits zircon, which acts as the supporting or surrounding material, and up to 5 metal or ceramic powders. But note that it's not selling machines. Instead, it offers part manufacturing services that fold in the R&D for your combination of part design, desired materials, and desired performance. In laser powder bed fusion, DMG MORI announced the LaserTech 30 SLM 3rd Gen. This machine expands the number of lasers, now up to 4, with full overlap between them, and includes bidirectional recoating with collision protection. The machine offers a number of improvements for performance and efficiency, including a rigid core structure that's standard for its machine tools, compensation for temperature changes as the powder bed absorbs the laser's energy using its floating process chamber that can expand in all directions, a new rapid build chamber exchange that employs internal covers put in place so that the machine's inert environment is preserved. Plus, the LaserTech 30 SLM 3rd Gen has a number of advancements that aren't awe-inspiring, but are fundamental to efficient, repeatable, and reliable operation. For those looking for smaller metal parts, approximately 5 to 50 millimeters being the sweet spot, Incus now offers its Hammer Pro 40. This machine offers high resolution and good surface finish. With this combination of size and quality, the company currently focuses on medical and dental parts, such as surgical tools and orthodontic brackets. Let me take a few seconds to explain how the process works. Its feedstock is a solid block that combines photopolymer and metal powder. Now, it's solid at room temperature, but if you apply a little bit of heat, it softens or melts. So within the machine, that block is heated to 45 degrees C so that the material can be spread into the build area. Once spread, it rapidly solidifies. Next, they expose the desired area to UV light to cure the photopolymer, which then binds the metal powder. In the machine, they then extract the green part, which means they remove all of the uncured combination of photopolymer and metal powder. Once the green part comes out of the machine, it's then off to debind and sinter. Incus stressed that this is a simple process and powder-free. There's a wide range of alloys supported, and Incus states that if the alloy is supported in traditional metal injection molding, or MIM, it can be used with the Hammer Pro 40. That is a lot of new product information to digest, but there was plenty of other news from the RAPID TCT show floor that I did not get to see. To reinforce how much activity there was, I'll briefly recap some of the news that came out of the event. In metals, Speed 3D announced Titan Speed, its largest cold spray 3D printer, and a new material, nickel aluminum bronze, for marine applications or where corrosion resistance is needed. EOS announced its planned integration of nLight's beam shaping lasers onto its 3D printers and the new M290-2 with two 400-watt lasers. Grimm Additive, formerly GE Additive, made an addition to its EBM lineup, the Spectra M, where M stands for medium size. HP had several announcements, including a build height increase for metal jet, new materials, a new texture library, and metal jet production services. Farsoon launched PA6 3D, a high-performance carbon fiber reinforced material, and it showed off its recently introduced FS721M-8 cams, which is outfitted with 8 lasers and its continuous additive manufacturing solution. Exact Metal announced a new automated powder handling system for its XM200G. And XJet debuted 17-4 pH stainless steel for its metal additive nanoparticle jetting technology. In polymers, Nexa 3D launched Zion carbon fiber-filled polymer for its material extrusion platforms. Union Tech introduced the Light 600 2.0 system, which uses stereolithography. Worth Additive Group announced new partners, Race 3D and Henkel, being added to its recently announced digital inventory services, and Prusa Research released the Pro HT90, its first high-temp fused filament fabrication printer. And one last item of news, this one's in the software category. Dendrite has released an upgraded version of its LPBF Pro software for advanced controls and new material development. As I said at the start, RAPID TCT was a fantastic event with so much to see and so much to learn. I've only scratched the surface, but I hope that in some way this video helps you to navigate your additive manufacturing future and build your roadmap. To paraphrase the comments in the first Executive Perspectives panel, be excited, but be honest and realistic about where we are, what is possible today, and what is needed for tomorrow. The future is bright, and RAPID TCT will reconvene April 8th to 10th in 2025 in Detroit, Michigan to assist you in your journey, planning, and execution. I'll be there, and I hope that you will be joining me.